Welcome to ClickMyProject.com. Let me discuss about the process and our approach for denoising and enhancement of extremely low light video. Let me see the abstract of the process and our approach for denoising and enhancement of extremely low light videos. The cameras for surveillance videos were sometimes placed in dim light conditions. The objects in the videos may be not clearly visible due to poor lighting conditions, a method that enhances the low illuminate videos without modifying much in the color informations were proposed. The video frames were filtered and tone mapped based on non-local means filter and Kalman filter. In the noise reduction process, two different noises like spectral noise and temporal noises were identified and removed in the process. In Kalman filter, the updation and prediction steps were included for the estimation of the noises. The performance of the process is measured on the basis of PSNR, SSIM, GCF, NIQE calculation. Low light noise is a major problem in all the surveillance systems. Most of the cameras have poor low light characteristics, which typically results in noises in the images, where noises commonly occurring in low light conditions were white noise or maybe speckle noise. For the camera blurs occurring due to the movements of the objects, the lightning in the form of flash is always viable, which reduces the original color informations. The color informations has to be preserved, and also the noises in the images has to be removed. The application of the noise removal process can be effective while we identify the type of noise and design the filter based on that. So in the proposed method, we enhance the images based on tone mapping, and also noise removal processes were applied in stepwise procedures to remove the noises occurring in the videos. The comparison of the performances indicates that the proposed method is more efficient for enhancing low light surveillance videos. Let me see the flow of the process. First, the input video is obtained. The video is converted into video frames. We add noises to the video frames manually because we are using videos from the benchmark datasets, and hence we have to there will be no noises in the videos, and hence we have to add the videos. After we obtain the noisy video frames, and also the amount of the Gaussian noises were also displayed in the base paper proposed. So after that, we identify the difference frame. So for the difference frame, so we use the current noisy frame, and the previous noisy frames were subtracted. Thus we identify the difference frames from the images. So after that, weighted matrix is calculated, and the prediction updation steps were repeated, which is the Kalman filter operations. Then the new generated weighted matrices were obtained, which identifies the noisy pixels in order to remove them from the input videos. After that, the Kalman gain is estimated, and finally it is denoised. The temporal noise reduction process is completed. After that, we move on to the tone mapping process. So in the tone mapping process, we tone map the images based on the gamma correction process. So in the gamma correction, the original color informations were preserved. That is, we convert the video frames into the frames which were extracted in pure white light conditions so that all the color informations were well preserved. Finally, we move on to the spectral noise removal process. In spectral noise removal process, NLM filter is used. So for temporal noise reduction, Kalman filter is used, and for spectral noise removal, NLM filter is used. After filtering, the video frames will be exactly denoised, and finally we measure the performances by comparing the denoised video frames and the input video frames based on the PSNR value and the other performances metrics. Let me see the running procedure of the process. If you want to run the code, select the file main no guy which is present in the source code folder. Right click it and click on run file. You will get the user interface in order to select any one of the videos present in the dataset. So we select any one of the videos which is present in the dataset. So the videos will be read and it will be displayed. So now the video is reading and it is displayed. After that, the videos were converted into frames. These are all the original video frames obtained by us, and this is the noisy video frame obtained. So we have ordered noise and this noisy video frame is obtained. After that, this difference frame is identified by the identification of the differences in the current frame and the previous frame. So due to the result, we obtain this difference frame. So after obtaining this difference frame, Kalman filter is the next process. So in Kalman filter, the videos were continuously going on updation and prediction step. So this process is executing and it will take some time for execution. So as we can see, the predicted frames and the updated frames were obtained, and after that we obtained the variance for that, and this is the new differences images identified, and these are all the noisy frames we denoised frames we got it, and this is the zone mapping process is now started. So for that, the histogram regions were calculated, and we calculate the tone mapping with clipping and without clipping in order to describe the comparisons between the original color informations that we have got while clipping the histogram of the input images. So after the Kalman gain has been estimated and it is compared after the comparison of the Kalman gain. So this is the overall comparisons, and after the tone mapping, this denoising process has been completed. So finally, the performances of the process is calculating and it is going on. So just we have uh, removed the noises from the input images, and also we have enhanced uh, we have enhanced the tone mapped frames in order to obtain the efficient denoised frames from the images. So as we can see, this denoising process is going on. So finally, this is the performances of our process measure. So for each frames, the PSNR value, SSIM value, GCF value, and NAQU values were measured. So thus we have enhanced the input low quality video frame based on the tone mapping process and the denoising process in order to produce the efficient enhanced video frames, and we have measured the performances of the process. Thank you.